Alright, let's look at forced undamped motion. Since it's forced, the right-hand side is non-zero, which makes it a non-homogeneous equation. And also there's no damper. In this case, C is equal to 0, right? And we're going to have an external force, which can be modeled by F0 cosine of omega t. So the equation is mx double prime plus kx is equal to F0 cosine of omega t. Right? So let's find the complementary solution for this differential equation first. Right? So characteristic equation would be m r squared plus k equals 0. Right? So if you want to solve that, and I'm going to just divide through by, actually first I'm going to subtract k. Then we have m r squared is equal to negative k. And then divide through by m. We get r squared is equal to negative k over m. And then we can take the square root of both sides. So you can see that the r is going to be equal to, so this is going to be an imaginary number. So plus or minus square root of k over m I, right? So I'm going to actually call this guy right here square root of k over m omega 0, right? So that this is just going to be plus or minus omega 0 I, right? So this way we know that the complementary solution x of c of t can be written as, so this is going to be a sine of omega t and a cosine of omega t. So I'm going to just write it as some constant c1 cosine of omega t plus c2 sine of omega t. Right? So actually omega 0 t, sorry about that, right? And where omega 0 is simply square root of k over m. Alright, so we got the complementary solution, and let's look for the a particular solution. Alright, in this case, I'm going to assume that omega 0 is different from omega on the right hand side. So here, let's assume that omega 0 is different from omega from the right hand side. Alright, so the particular solution can be expressed as x of p is equal to, right hand side is cosine of omega t, so you consider all the derivatives, so it's a cosine of omega t and a sine of omega t. So we can probably write it as a cosine of omega t plus b sine of omega t, right? So since we're assuming that omega 0 is not equal to omega, there is no overlap with the complementary solution. So this is going to be the form of the particular solution, right? So once you get the form of a particular solution, we're going to just take a couple derivatives and plug it into the equation so that we can find a and b. All right, so let's do that. All right, so first derivative, x of p prime of t is equal to, right? Derivative of a cosine of omega t is negative omega a sine of omega t, right? And derivative of that is plus omega b cosine of omega t, right? Then we have x of p double prime, right? And the derivative of that is negative omega squared a cosine of omega t, and minus omega squared b sine of omega t. All right. So then we can just plug this into the differential equation here. So let's do that. So we're going to have to do m x of p double prime plus k times x of p. All right, so let's do that. So we have to multiply the second derivative by m. So we're going to get the negative m omega squared a cosine of omega t minus m omega squared b sine of omega t, right? So that's the first term. Then we have to multiply k and x of p. So it's going to be plus, maybe I'm going to go, let's say I'm going to go here, plus k times a cosine of omega t plus k times b sine of omega t. All right. Then we're going to collect the like terms. So I'm going to collect the cosine terms together. So here's the cosine terms here, and here's another cosine term here. So by combining that, we're going to get, let's see, I'm going to pull out a. So you're going to have a is pulled out, and also cosine of omega t. Then you have a k minus m omega squared, right? And then collect the sine term, and you're going to get, let's see, you're going to have b sine of omega t. Then you have a k minus m omega squared, right? But remember that this has to be equal to f0 cosine of omega t, right? Since right hand side has no sine term, so we have to make sure that the coefficient of the sine of omega t is equal to 0, right? Which actually gives us b value, right? Because this has to be equal to 0, and this is going to be just b is going to have to be equal to 0. All right, and unless k minus m omega 2 is 0, but since omega 0 and omega are different, so these are never 0. So b has to be 0. All right, then we know that this implies that we have to match the coefficient of the cosine omega t here and f0, right? So this will give us quantity k minus m omega squared a has to be equal to f sub 0, right? So we can figure out a. So divide through by k minus m omega squared. We can get a to be f0 over k minus m omega squared, All right, so we have a particular solution. So x of p of t is equal to f0 over k. Actually, I want to do one more thing here. Omega 0 is square root of k over m. So which means that if you square both sides, we have omega 0 squared is equal to k over m. Then we can multiply both sides by m. So we have m omega 0 squared is equal to k. So we can rewrite this guy as, right, we're going to plug in k is m omega 0 squared. So we can rewrite this guy as f0 over, right, both have m. So I'm going to pull m out. Then you have omega 0 squared minus omega squared.